my name is Canis Kwa, and I am a program manager on the Azure IaaS Compute team. And thanks for joining me today. Today we're going to talk a little bit about how to decide between different Azure virtual machine sizes. Throughout these sessions, we're going to talk a lot about different technologies in Azure. I'm going to be focusing specifically on the ones that are circled in red, basically virtual machine sizes and virtual machines in their different sizes. As well as some of the different options and configurations that you have for both premium storage and standard storage. And I'll show how you can manage these and how work with these VMs through the portal. One thing to keep in mind whenever we talk about Azure is that there's 19 different data center regions across the entire world. So we actually have a really huge global presence where each different region supports sometimes different sizes, sometimes the same sizes. So as we get further on, we'll talk a little bit more about how to actually figure out what regions support which sizes. So one common question that I often get from when I'm talking to customers is, well, how do I even decide which VM type is right for my application? So whenever Azure started, we only had a single VM type. And now that we've grown in the number of families that we actually support, so this has become a really important question for customers to answer for themselves in terms of how they're actually going to pick the right VM sizes for their application. So first, when we started, we got a lot of customers asking about dev test scenarios. So they would say, I need a VM spun up so that I can test out whether or not my OS image is going to crash or not, whether or not some configuration that I've set up is going to work. So dev test scenarios were very important. They needed to be able to spin up these VMs pretty cheaply and pretty quickly, and then be able to spin them down when they're finished. The second type is high performance computing applications. So customers would come in with these life science workloads, with oil, gas, entertainment industry workloads, and say, I need to run these jobs across thousands of instances, except I don't want to pay for all that hardware. I really just want to use those sizes, and then I want to spin them down when I'm done. And those types of applications soon transitioned into real enterprise applications where customers are actually bringing their production workloads into Azure. And now we have the capabilities to support those types of workloads really well as well. So the main point here is that Azure has all of the different sizes that you might need to run your workload and right-sizing the VM to your workload. So let's talk first about the A-series family. So we sometimes call this the classic VM size, in that it's the first set of sizes that we have offered customers. The first, we sort of think about these as the highest value VM size because they're pretty cheap, they're still pretty powerful, and they allow you to run most of your general purpose workloads. We have sort of two flavors of these. There's the general purpose, and then there's the high memory workloads, which have a higher memory to core ratio. So, but let's focus first on the general purpose sizes. So these are really our A0 to A4 sizes. They come in two different flavors. One is basic and one is standard. Basic is the very vanilla type of VM that you can get. It is slightly less powerful than the standard VM sizes, but still fully functional. You're able to bring whatever images that you need and run them with the basic VMs. The only difference is that the basic sizes don't allow you to use the Azure Load Balancer. But the standard sizes, both of these sets of sizes will run most workloads, and most people end up using these sizes. Now, certain types of workloads, say if you're running SQL, which charge per core, you might want to say, oh, well, I need a really big memory footprint, but actually I don't need as many cores. I'm not actually able to drive that number of cores. So we now offer these high memory configuration VM sizes, which are really targeted at running workloads like SQL. Now transitioning, when I talked about high performance computing sizes, We also introduced a set of sizes. First, we introduced the A8 and A9 VM sizes, which are the fastest processors that we actually run in terms of frequency today. And they're really, again, targeted toward those high-performance computing scenarios where you really need those really powerful computers to drive your workload. The other added benefit of these A8 and A9 VM sizes is that they have the built-in RDMA NIC, which allows really high messaging between instances. So let's talk a little bit about what big compute is. Say you have many individual tasks and you need to run those on many different computers. You need to spin up a bunch of these VMs in parallel and then insert those tasks and those jobs to run on those individual VMs. This is used in a number of different scenarios like climate modeling, engineering, stress analysis. I mean, we have financial analysis. A lot of our customers who come in to run these kind of workloads need these really fast, really powerful VMs. But then again, they don't want to keep them around. They want to run that job and then they want to shut them down. So the two main types that we see, one are what we call embarrassingly parallel, meaning that they don't the individual instances don't have a high level of coupling. They're able to run somewhat independently. We have this notion of a parametric sweep, meaning that we're able to run run the same job with different parameters on different types of workloads, on different instances. And then the other type is tightly coupled. So these are the ones that we were talking about before that use that RDMA NIC to give you that really fast interconnection between the low latency, high throughput connection between adjacent VMs. And so one example of this, I'm going to show a little demo that basically illustrates exactly how powerful this can be. So this is a simulation that is running 750 extra large VMs. So that's about 6,000 cores. And normally we wouldn't take those 6,000 cores from our customers, but for the purposes of this demo, we really wanted to show exactly how powerful Azure can be. And each of these VMs are identical, and these are all being managed through HPC Cluster Manager. And what we're seeing is that we're going to create a job and use it on each one of these and run this job on each one of these instances. It's what we call a parametric sweep. So we're going to run a different variation of parameters on each of those instances. And then when we kick off this job, what we're going to see is a heat map of the CPU utilization that this job, that each of these VMs is basically that shows how each of these VMs is being used. So we can see once we transition over to the heat map that each square represents a node that's running, so one of these 750 nodes, and each of those little bars represents the core. And as the core gets more and more utilized, it gets green and it starts to fill up. And so now we see that the entire job is running, and then as the job finishes, it starts to drop off. We start seeing that the cores are not being used as much, and eventually these jobs all finish, and it writes a very clever message. All your base R belong to us, which is a zero-wing reference for those who are nerdy like me. So this really shows how powerful these large-scale jobs are in Azure using these HPC type sizes. So now let's move on to some sizes that we've introduced more recently. The first one is the D-series family. The D-series sizes, we actually, funny story about the naming, we wanted to call it we started off with A sizes, right? So now we're like, okay, well, next letter in the alphabet is B. But B sounded too much like basic sizes, which we also just introduced. And then C happened to be the name of a set of VM sizes that were being used by our competitors. So instead we went with D. So that's how much thought and planning we put into the naming. But these sizes are about 60% faster than the A series, the A0 to A4 CPU. And they have a larger memory to core ratio. The general purpose sizes of the D1 to D4 are actually 1 to 3.5 gigs of memory, 1 core to 3.5 gigs of memory. And the big thing about these versus the A series is that we give you this local SSD storage. So that local SSD, it actually gives you about 5 times the performance of the spinning disk drives on A series. So this allows you to, say you're running against SQL and you need to put your tempdb on the temporary storage. Now that's just going to be a lot faster because it's being serviced by a local SSD. And so the other major thing that we introduced as part of the D series family is now this introduction of premium storage. So premium storage, previously we only had standard storage, which is great for most types of workloads. But you can spin up to 20 gigabytes per second of disk traffic to that storage account, 20,000 IOPS. But the problem is that, say you were running a workload that required really low latency or really high bandwidth, that standard storage wouldn't cut it. So we introduced this new offering called Premium Storage, which is really targeted at those types of applications that are low latency or that require that low latency, high bandwidth connection. And we introduced this ability for your to create these premium storage disks, attach them to the DS series VMs, and you can attach up to 32 terabytes of storage to each one of those VMs. That you get 64,000 IOPS per VM, 50,000 IOPS per disk, and it has that really low latency connection to your disks. So you can run those kinds of workloads. And the work that we did was basically to completely refactor that cache, the cache that helps to serve those I/O requests, which allows us to give you this kind of performance. So if we go over to the D series VM, we can actually see what that looks like under the covers within this VM. So we have this is just a normal D2 VM, and we see that you can get 100 gigs of temporary storage with your D series. But then once we go over to the DS series, we see that that's now dropped down to 14. So where did the rest of that temporary disk goes? It goes to the host, which is running that virtual machine, and it's being used to cache to give you that really high performance cache. That gives you that performance for those DS series machines. So another thing that we commonly hear is it's really difficult to resize a virtual machine. And so as part of our effort to revamp IaaS virtual machines by bringing virtual machines v2, we have some improvements here that will help you resize the virtual machine. So we look at the RDFE virtual machine. This is the V1 stack. We're able to see that there's only a certain set of sizes that you're able to resize to. And so this is probably very familiar to you. You have A0 through your A7 sizes, and then your basic sizes, and that's pretty much it. But one thing that and so basically, it's really problematic if, say, you want to spin up a D series VM and you can't, because even though the region actually supports that size, but because of the scale limit boundaries that we have on these set of sizes, then we're not able to allow you to resize the VM. But with our new Azure v2 stack, that we've now improved that ability. So if you go over to your settings on a V2 virtual machine, and then you go down to your sizes, that if the VM sizes, if your VM is stopped, then now we're able to allow you to resize the VM to any number of different VM types that the region supports. So say, for example, you'd say that this VM size is great. You know, I can run up to a D14 or a DS14 VM size, but it's not big enough. I need something bigger than that. So we recently announced the G series family. So the G series family are really the monster VMs that Azure supports. These are 32 CPUs, 32 CPU cores. These are Haswell cores. They're physical cores. They're not hyper-threaded. And so you get the full power of that physical core. And it's 448 gigs of memory. This is of memory, not disk, which is huge. You can run tons of, you can run these really large scale workloads on this kind of size. And for the G series, that we also give you 6.5 terabytes of local SSD. You know, again, running the fastest, latest generation Intel processor. Most recently, we also announced that premium storage is now supported for the G series in the form of a new VM size called GS series. These GS series VMs allow you to attach these premium storage disks that we had talked about. So the same thing that you're seeing here, you know, right now we see about 6 terabytes, 6.5 terabytes of local SSD. But that drops down whenever you go to your GS series VM. And again, all of that storage is being used for this really high performance disk cache that you get whenever you're running a GS series with premium storage. In summary, we see this spectrum of VM sizes that you can pick from in order to match the VM size to your particular workload. From the left, we see that you have the highest value. This is really these A series sizes allow you to run most workloads, and but if that's not enough, you can scale up then to the D series. D series has SSD storage, has faster CPUs, but sometimes, you know, for certain workloads, that's not even enough. You have to go all the way up to the G series, which has the most memory, the fastest CPUs, and up to 6 terabytes of local SSD. And so that's really a summary of all the different types of VM sizes that we offer in Azure. I thank you for watching and tuning into this video. I hope you enjoyed it. Thank you.